Hello, accounting students! Today, we're diving into a powerful analytical toolkit, one that helps you master one of the toughest parts of business, uncertainty. We're going to see how you can actually turn all that randomness from a liability into a real competitive advantage.
So let's start with the big question, right? Whether you're trying to figure out inventory levels, value a new project, or plan for capacity, you are always dealing with variables you just can't control. So how in the world do you make the optimal decision when the future is so random? Well, that is exactly what we're here to figure out today. Here's our game plan. We'll kick things off with the big idea behind operations research. Then we'll get really practical with modeling in Excel. After that, we'll learn how to find the best answers, and we'll wrap up by looking at some amazing real-world applications. Okay, first up, let's define this field, operations research, which you can think of as the discipline of making better decisions. So, operations research, or just OR for short, think of it as the science of making smarter choices. It's a whole field that's dedicated to using math and data to find the best possible solutions to really complex problems. And the goal? Well, it's usually to maximize profit or, minimize costs and risks.
Now, a core principle of OR is rigor, and as future accountants, you are going to appreciate this. Any simulation that you can actually rely on follows a very structured, auditable process. You have to move methodically, from defining the problem to building a model, validating it, and then finally implementing a solution that's quantifiable. It's all about creating a decision process that is both incredibly powerful and totally defensible.
But what happens when a system has way too much randomness for a simple formula? When you just can't calculate a single right answer. Well, that's where simulation comes into play.
Simulation basically lets us create a virtual copy of a real-world process. It's like a flight simulator for business decisions. It allows us to run thousands of experiments, testing different policies, changing staffing levels, adjusting inventory rules, all in a completely risk-free digital environment, before we spend a single real dollar. Now, there are a few different types of simulation out there, but for business, we are laser-focused on what's called discrete event simulation. It is absolutely perfect for modeling processes that happen one after the other, like customers arriving at a bank, trucks unloading at a warehouse, or invoices getting processed. The system literally jumps from one event to the next. So how do you actually build one of these models? Well, you break the system down into these essential building blocks. You've got your entities, like customers, who are using resources like tellers. Then you have events, like a customer arriving, which trigger changes in the system. And from all that, we can measure the delays, the waiting time, which is very often the key thing we're trying to minimize. Okay, let's pull this out of the world of theory and into a tool you probably use every single day, good old Excel. But before we dive in, a quick word of warning. This quote should honestly be a little scary. See, to build models we can actually trust, we can't just throw formulas into cells and hope for the best. We need something called disciplined spreadsheet engineering, a concept that should really hit home for anyone going into accounting, where accuracy and auditability are everything. Think of these principles as your guardrails against making a huge mistake. By separating your inputs from your calculations and your outputs, your model becomes transparent and way easier to audit. And by managing your formulas correctly and making sure your results are repeatable, you build a tool that isn't just powerful, it's trustworthy. Believe it or not, the magic starts with one surprisingly simple Excel function, rand-R&D. All it does is generate a random number between 0 and 1. We then use other formulas, like the ones you see here, to transform that simple little number into a realistic business variable, like fluctuating customer demand or unpredictable service times. And this is where it all comes together. Each row in the spreadsheet represents one customer moving through a system. Their arrival is random, but the key piece of logic, the absolute heart of the model, is that max function for the service start time. See, a customer can only start getting served after they've arrived and after the person in front of them is finished. That simple logic lets us calculate the one thing we really care about, waiting time. So, great. Our model can now describe what might happen across thousands of different scenarios. But that's only half the story. That's descriptive. We want to be prescriptive. How do we find out what we should do? Well, for that, we need an optimizer. And for that, we bring in the heavy hitter, Excel Solver. It's a fantastic add-in that basically automates what-if analysis. You just tell it your goal, your objective cell. Then you tell it which decisions you can control, Those are your changing variable cells. And finally, you give it the rules of the game, your constraints. Then you just hit go, and Solver will churn through thousands of possibilities to find the very best solution. Now, this is absolutely crucial, so listen up. You can't just use any old solver method. Because our models use functions like VLOOKUP or IF, the results can be non-smooth or kind of jumpy. The standard methods will just fail on this type of problem. You must use the evolutionary method. It is specifically designed to handle the choppy kind of output that simulations produce. Get this part wrong, and your optimal answer could be way off.
All right, enough theory. Let's talk about where the rubber meets the road. Where is this stuff actually being used to solve massive, multi-million-dollar problems? In the world of supply chain and logistics, simulation is absolutely fundamental. It's used to find that perfect inventory balance, minimizing the high costs of holding inventory without risking stockouts and losing sales. We're talking about companies using this to design entire distribution networks worth billions of dollars. And for you folks heading into finance, this is a core tool. Monte Carlo simulation moves you beyond a single point estimate in a DCF model to seeing a full probability distribution of outcomes. It gives you a much more sophisticated, much more realistic understanding of risk and value. And it's not just for products or money. In any service industry, from call centers to hospitals, simulation is used to optimize that critical trade-off between operating cost and customer satisfaction. It can answer really important questions like, how many nurses do we actually need on staff tonight to keep patient wait times below 15 minutes? So, if there's one big takeaway today, it's this. What we've talked about is a fundamental shift in thinking. It's about moving away from the illusion that there's a single, certain future. Instead, it's about embracing uncertainty, understanding the entire range of possible futures, and making really robust decisions that are prepared for whatever comes next. And that's the leap. This is the jump from just doing descriptive analytics to providing truly prescriptive strategic guidance. Look, having the skills to build a model that shows what could happen, that's valuable, for sure. But having the skills to find the optimal path forward, that's what will make you an absolutely indispensable strategic advisor in your career.